In this video I will show you what analogWrite is and why it is more like analogWrite. On my Arduino Uno there are 6 analogWrite compatible pins. These are marked with the tilde symbol and one of them is pin 3. Pin 3 is also a digital output, so you can use digital write 3, high to turn it on, and then it has 5 volts, which is our supply voltage of Arduino. Or you can use digital write 3 low to get 0 volts. Analog would be something in between. For example, analogWrite 3 2.5. However, this is not how it works, because the second argument of analogWrite is a number between 0 and 255. If we write analogWrite 3 0, it will output 0 volts. And if we write analogWrite 3 255, it will output 5 volts. So if we take 255 divided by 5 and multiply it with 2.5, it will be around 127. So analogWrite 3 127 should give us 2.5 volts. However, Arduino Uno is not capable of outputting analog voltages. It will output 2.5 volts on average. How could this work? Arduino can output 0 volts and Arduino can output 5 volts. How could we generate 2.5 volts on average? Arduino does it like this: 5 volts for 50% of the time, 0 volts for 50% of the time. So on average we have 2.5 because half of the time we have 2.5 more and half of the time we have 2.5 less. So on average 2.5. Now you may say my life has been a lie. This is not analog. And you're right. This is called pulse width modulation. And actually this is not only used by Arduino, this is used by a lot of devices. Now what happens if we want a voltage that is not exactly half of our supply voltage? Let's say we want 3.75 volts. The on time will be increased and the off time will be decreased so that on average we get a higher voltage. Now the same thing works with voltages that are less than 2.5. On average, we have less than 2.5. If we take a closer look at this, the signal repeats itself and the period duration using pin 3 is around 2 milliseconds. In this example, it would be on for 0.5 milliseconds and then it would be off for 1.5 milliseconds. So on average, 1.25 volts. You may ask yourself, who needs a signal like this? This is something, but not analog. What could we do with something like this? In fact, a lot. Let me show you 2 examples. The first example is take the signal and put it into an LED. A period duration of around 2 milliseconds can be translated into a frequency of around 500 Hertz. And 500 Hertz is faster than our eyes. And actually most of the LED lights that can be dimmed use pulse width modulation to dim the LEDs with a frequency that is high enough so that you can't recognize it with your eye. Sometimes if the frequency is too low, you might see it if you move your hand around. Sometimes you may also see it if you take a video with your phone, especially in the slow motion mode. So try this at home. Maybe you find a light that is actually using pulse width modulation. If it's not dimmable, maybe you just find a crappy light. These also exist. Another example is an electric motor. An electric motor is a very slow system. So if you use 500 Hertz at a small electric motor, it will not turn off and turn on and turn off and turn on. It will just run. 2 milliseconds is nothing for a motor. Yes, its velocity will not be perfectly constant, but you will not be able to recognize it. Let me show you how analogWrite works with Arduino. First, let's do it manually without analogWrite. I will use pin mode 3 output because pin 3 will be our output. And then I will generate 2.5 volt using pulse width modulation, but not using analogWrite. I will do it using digital write. Digital write 3 high and then delay 1 millisecond, and then digital write 3 low, delay 1 millisecond, over and over again. Let's upload this to our Arduino. In order to see what's going on, I will connect it to a logic analyzer. If I look at the signal, it looks like this. Around 2 milliseconds period duration and around 1 millisecond on and 1 millisecond off. So we could generate a signal like this also using digital write. But the problem is your loop is very busy. You can't do anything else than generating this signal, and that's not much, right? You just generate this signal. Here is how you use analogWrite. I will remove all of this stuff. We can keep the loop empty. After configuring pin 3 as output, I will analogWrite 3 127, because 127 is roughly half of 255. And then let's upload. And the signal now looks almost the same. Around 1 millisecond on and around 1 millisecond off. Let's reduce it to 64. Now the signal looks like this. On time is only around 0.5 milliseconds, which is 500 microseconds. The period duration stays the same. And we will do it over and over and over and over again. And by using analogWrite, you use this one command and then Arduino does it effortlessly. You can do whatever you want inside of your loop and the signal will stay perfect. It is a little bit like multitasking, although it is not really multitasking. It is in fact using timers. I will talk about timers in another video. Here comes your exercise. I would like to use a potentiometer to control the brightness of my LED. How can we do this? Okay, I will use a resistor for my LED. You will need 150 ohms and the flat side is the cathode. So this side will be connected to ground. This side right here will be connected to our output 3. And you see the LED is already glowing. The potentiometer looks like this. You have a beginning and the wiper in between, and it pretty much is like two resistors like this, and the total amount stays the same. If you rotate this knob, you change the values of the resistance. So if we put 0 volt here and 5 volt here, you can change the value of the wiper between 0 and 5 volt, which is very nice. So we connect one side to ground, to 0 volts, and the other side to 5 volts, which can be found here. And then the wiper, let's say to analog in 0. And now I would like to use this knob to change the brightness of the LED. One last hint, analog read, analog write. And just a quick reminder regarding the resistor, this resistor and an LED like this. This will be our pin and this will be connected to ground. So if the pin is on, then we have 5 volts here across everything, and this will be around 2 volts. And so we will have around 3 volts on the resistor. Resistance equals voltage divided by current. And we have 3 volts on the resistor divided by 0.02 amps, because this diode, according to its datasheet, requires 20 milliamps. And this leads to 150 ohms. Pin mode 3 will stay as output. but we delete this analogWrite. What we need to do is we need to read the potentiometer. So analogRead A0, you can also say 0, but we need to store it somewhere. AnalogRead is a number between 0 and 1023. So we can't use the byte variable. We need to use integer. Let's call it potentiometer. Int potentiometer equals analogRead 0. So now that we have the value of the potentiometer between 0 and 1023, the next step is we take this value and put it to the LED. Using analogWrite, pin 3, and the value is potentiometer, but we're not quite there yet because potentiometer is 0 to 1023 and we need a value of 0 to 255. So what should we do? We can divide it by 4. End of statement. Let's upload this. Now I can use the potentiometer to control the brightness of the LED. If this video was helpful, please like and subscribe to this channel if you're ready to dive deep into the world of Arduino. Thank you for watching. See you in the next lesson.